G'day guys and welcome back to Chalk Talks, where I discuss blacksmithing, bladesmithing, metallurgy and more. Today we're discussing distal taper. This video is actually going to cover tapers in all dimensions when talking about a knife, so tang and blade, because this was actually suggested to me by a commenter on my most recent video about knife design and the overall knife design, and it's a piece that I missed out on when talking about blade design, and the tapers are incredibly important, and understanding how they can affect the design and also how they can be produced is incredibly important. So I figured I'd do a dedicated video just to this topic. The first step in understanding profile and distal tapers is to understand exactly what they are. So profile tapers are as it sounds. When you look at the blade in profile along the flat of the blade, the taper will happen in the blade. Now, you can have multi-profile tapers and stuff like that, and we'll get into that later. But basically, when referring to a profile taper, you are referring to a taper that goes from the shoulder to the tip in any direction. Distal tapers are if we lay that knife on its side or on its flat, then we are seeing a taper down the spine or down the thickness of the blade. So this is a dagger, for instance, because it's easier to show a profile taper. The profile tapers and also distally tapers. And so obviously we have much more material at the shoulder than we have at the tip in both cross sections. So those are the two main differentiations when we're talking tapers. Profile taper comes in many forms and is normally a part of making a knife. Most knives have some form of profile taper. And normally you will see it tapering from the tang shoulder to the tip. Right, so here we have a representative of a dagger, a Bowie knife, and a tanto, all of which have profile taper. Now, with the Bowie and the tanto, it's a little less obvious. Like, obviously, I've a little over-accentuated the Bowie a little bit to make it easier, but this tanto does actually have profile taper, and in a lot of European swords and that kind of thing, they will have some degree of profile taper, even if they don't appear to. And that is purely to limit the amount of material at the tip, and this helps with balance. And distal taper is 90% about balance, and profile taper is the same, 90% about balance and a little bit more about structural integrity, and we'll get onto that later. But for the purposes of profile taper, we are limiting the amount of material at the end to provide a lighter tip, which means more weight towards the hand, which means a slightly nimbler, easier to use blade. It also provides a thinner cross-section for piercing. If you're using like a dagger or a fighting knife, you're wanting to penetrate things, it's better to have a narrower cross-section. So when you're designing your knife, you're going to want to think about having a profile taper, and you may want to profile taper down to the tip, but where would you see a profile taper that doesn't taper this way? If we're discussing historical examples, one of the perfect examples of a reverse, what I would call a reverse profile taper, is the sax, the Scandinavian or Anglo-Saxon broken back sax. And that is because in most of the copies that we have, or most of the original pieces that we have from the historical record, they are narrower here at the tang shoulders than they are at least at the peak. Obviously, they then profile taper again down to the tip, and almost all blades will profile taper to the tip unless they're something like a competition chopper, which doesn't have a tip, so to speak. But coming further close into our history, we've got the Green River skinner, or most skinning knives have a profile taper that tapers out towards the end. Now, this has multiple functions. It can provide extra meat in the end for chopping, but it also provides a wider cross-section of the blade, which now allows for a narrower cutting edge, a thinner cutting edge, for the same angle, because obviously the angle between if the spine thickness is the same in these two areas, which it shouldn't be, but that we get onto later, then this distance here is going to be a much more obtuse angle than this distance here. So this is going to provide a slimmer cutting edge, and obviously with the Green River we have that extra belly for slicing, which is in my bladesmithing or my blade design video. So there are blades that do swell like this. Another example is one that I didn't draw here, but I will quickly. Very badly. Let's narrow that out a little bit. Leaf-bladed daggers. Leaf-bladed daggers tend to have some form of reverse profile taper, and then obviously another profile taper down towards the tip to provide that piercing point. And kukris, again, have that reverse profile taper. Profile taper, it allows you to put the material where you need it. So if you need extra meat towards the tip for extra heavy chopping, then you'll profile taper from the guard out towards the tip in the reverse of what you would normally see, which is tapering from the tip down towards the shoulder. Now we get into the subject of the video and also the subject of the commenter's question, which is distal taper. And distal taper is something that is relatively well understood these days, but is still somewhat enigmatic when it comes to knife making in general. Some people will tell you that there's only one way to do it. There's some people will tell you there's a million ways to do it. All of them are right, but also all of them are wrong. Distal taper is basically a taper that happens on the lateral edge of the knife. So we're looking here, for instance, at the top-down approach to a knife. Now, knives are all tapers. The bevels are a taper. Obviously the tip is a taper. There are always tapers in knives. Very few things are dead straight in a knife. But the distal taper is incredibly important in most knives because it is the thing that provides the best weight reduction, right? Because the more weight you reduce in thickness, you're going to reduce a lot more weight than if you reduce in profile, because the more you reduce in profile, the more obtuse your edge is going to be, because in order to retain some form of structural integrity, whereas you can thin something and keep it relatively wide and have an incredibly good cutting implement that's also strong enough to withstand the abuses that it may undergo. But as you can see in this representative piece, there is a taper both from the tip to the shoulder, but also from the shoulder to the end of the tang. And this is quite common in especially full tang knives to provide better balance, because obviously you're trying to make up for the fact that you're gaining weight from the handle material. So you don't want all of the weight back here, because then it feels too rear heavy and it feels awkward in the hand. I can tell you that from experience. Whereas you're also distally tapering this way, which means that you don't want too much material as well back here. So you distally taper in both directions to provide a balance point that hopefully centers around the front of the blade, or just in front, just at the forefinger when you're holding the knife. Now, distal taper provides another benefit, which is the key benefit in a lot of things that we're talking about, especially in stuff like filleting knives and the ABS Journeyman Smith test. It's incredibly important, is that it provides flexion, much like a fishing rod, where the fishing rod is obviously thicker at the base and narrows towards the tip, and that allows it to flex evenly across its length rather than flexing just, it bending in the middle and creating a hinge point. This is what that allows, that is what the blade is allowed to do with distal taper. So if this was not distally tapered, any bending force would happen anywhere along this point, right? It would obviously just flex anywhere along a straight bar. Whereas in this case, if you were to apply torsion to the tip, or a torsion with the handle across the tip, it would actually flex across this entire length, growing in robustness as it gets towards the, I'm not sure that that's a word, but growing in strength as it gets towards the shoulder of the tang. And so this provides the most strength here, but also a little bit of flexion here in order for the blade to be more robust when being pried with, which you shouldn't do. But that is one of the key things. When the ABS test, when they do their 90-degree bend, one of the things they look for is that there are no hinge points in the blade. They don't want to see a blade that does this, for instance. They want to see a blade that, although it curves in an arc, like that. Because that tells them that they have proper distal taper, and that it's actually flexing across its entire length rather than just flexing in the single point because it has no distal taper. Distal taper has another key advantage, which is that it provides less material at the tip, which means that you've got more cutting performance. Again, that narrower cross-section is going to provide you a slimmer cutting profile, which we talked about in sharpness versus edge geometry, for slicing. And most of the blade use that you're going to get out of most knives is going to happen towards the final third or the final half of the blade. And so therefore, that needs to be where your best cutting performance happens, and that's why distal taper is important. There are many kinds of distal taper, but they're normally split into three whole sections, which is a flat distal taper, a stepped distal taper, or a flat and distal taper, and then a compound distal taper. And these three normally are used in very specific circumstances, though the stepped and flat tend to be used interchangeably. Flat distal tapers denotes that it tapers from the shoulder to the tip. There is no flat section or parallel section on the blade anywhere. And this is quite common in stuff like tantos and pucos and stuff like that, where they have no ricasso, because they can taper straight from that tang shoulder. They don't require a flat section in order to work. And so flat is normally going to be seen on ricasso-less traditional blades, and traditional blades where the maker doesn't particularly want a parallel ricasso. And I personally don't tend towards parallel ricassos. I tend to have a full flat distal taper where the distal taper goes all the way to the shoulder. The stepped distal taper is the second kind, where a ricassoed blade, or even some blades that are more traditionally built, have a parallel section before they distally taper. Now, technically, even on a flat bar made knife, once you grind bevels on it, even if they're saber ground bevels, the area where that saber ground bevel goes up towards the spine, that is a distal taper. It's a very, very small distal taper, but it is still a distal taper. So stepped distal tapers are what you're going to see very commonly in most production knives. You're also going to see them in a lot of ABS knives and any knives that are made by someone who has a surface grinder, because they're going to surface grind their flats, their ricasso, or whatever area of the blade that they're flattening, and then they're going to grind in or forge in their distal taper, and so normally you'll have a parallel, then a distal taper. Compound distal tapers is something I don't see talked about enough, and it's something that's actually very dear to my heart because it's very commonly found in swords, and especially Victorian period swords from England and France and most of Germany and Spain, all that kind of stuff, going back right to the Middle Ages. Very commonly they would have overly thick shoulders, anywhere up to 10 millimeters or 3/8 of an inch, which would then very quickly, and in a concave rather than a flat, then taper down to around 6 millimeters to maybe 4 if it was a very thin blade, and then it would continue as a flat taper all the way to the point, which it would get down to 1 millimeter in some cases. So compound tapers are incredibly historically accurate, but they're also incredibly useful because they provide an incredibly robust tang cross-section, right? So the area at which the handle attaches to the blade, whilst also still providing that lesser weight at the tip and that nice flex of a sword blade, which is necessary for most sword blades in order not to snap. The other reason that it was very popular is because if you have a standard flat distal taper, there isn't a significant amount of more material at the hilt unless you have an incredibly thick piece of steel. And if you have a 3/8 piece of steel here or a 10 millimeter piece of steel here and flat taper, you've got a lot more material in your blade than you do with a compound distal taper. So what would happen is you'd end up with a much thinner tang cross section, which means that it would be more likely to break off at the handle. And in combat, a blade that is compound distally tapered is more likely to break at one of the weaker points, the thinner points of the blade, but half of a sword is still useful, whereas a handle and a blade that's no longer attached isn't as useful. So therefore, it was more common to see the compound distal taper in historic pieces and pieces that I hope to recreate myself. And yeah, it's an incredibly useful technique, but it's only used mostly in swords. You do see some of it in traditional, kind of Malaysian and Indonesian things like the kris, and a lot of daggers from that area, and anywhere where you see fully forged blades that have distal taper in them. A lot of the time they will have a compound distal taper purely by nature of the fact that the person has forged it in rather than grinding it. But let's get into how we actually apply all of these. In practical terms, it can be split down to two methods, right? Either you grind your distal taper in or you forge it in. Now, if you're a knife maker, so you're a person who does all of their knife making by stock removal, then obviously you're going to be grinding all of it in. And it's not impossible to grind a compound distal taper in. It's just a lot more difficult, right? You're going to have to do a lot more layout and a lot more careful grinding, and you're going to remove a lot of metal in order to get a compound distal taper. So most of the time, if you're grinding in a distal taper, you're going to be grinding in a flat or stepped distal taper, because it's the easiest thing to do. With a flat distal taper, you can literally hold it against a flat platen and have the grinder mark stop at the shoulder and put most of the pressure on the tip, and you're going to initiate a distal taper that way anyway. And as a stepped distal taper, when you're grinding your bevels, if you're using flat bar stock that's been surface ground or is precision ground from the shop, as you grind your bevels, if you're grinding full flat bevels, if you allow the bevels to pass behind the spine, not at the not at the plunge cut, which is something I may do a video about, but if you allow those to pass through so that the actual bevel angle is coming through the blade rather than just down the blade, you'll end up with a natural distal taper that way anyway, and you'll still have your parallel ricasso, which is going to provide you a stepped distal taper. Whereas if you're forging your blades and you want to forge in your distal taper, the two easiest are the compound and flat distal tapers. The reason, obviously, for the compound taper is because you can push the material where you want it and don't have to spend hours and hours trying to lay out where you're going to forge it. You can literally take a 3/8 or 10 millimeter piece of steel and forge that compound down without having to remove a lot of material. You're just moving it. And the other reason that flat rather than stepped is easier is because it's incredibly difficult. Anyone who's done any kind of blacksmithing will understand that it's incredibly difficult to create parallel surfaces, like perfectly parallel surfaces. You can create somewhat of a stepped distal taper by using a flatter and by measuring things or using jigs and that kind of thing. If you're using like a power hammer or a press, you can normally get away with it. But the majority of the time, you're going to introduce some form of flat distal taper purely just by the dint of the way you're forging. And so what I've found is that even when I've tried to make stepped distal tapers with a flat ricasso, I almost always end up with a slightly tapered ricasso, just naturally. So I don't even try. And if I want to create a stepped ricasso, a stepped distal taper after I've forged it, then I will parallel out my ricasso from the forging. And I'll do that before I do anything else. So yeah, when you're approaching your distal taper, understand what kind of distal taper you're aiming for, and then choose your method accordingly. In application, distal tapers all have different kinds of specialities, and as I said before, compound distal tapers tend to direct themselves towards swords and things that are going to undergo a lot of shock, but you want to maintain a fine cutting performance. When we're talking about strength, like the strength of the blade in resistance to flexion, then a stepped blade is going to be the strongest because it's going to have the most material, because it's going to have a period of material that is parallel, which is the thickest piece of material that's going to be allowed to have. That means that it's going to resist the flex as much as it can for the material, but it's also less flexible. So the most flexible is obviously going to be the flat or the compound, because a compound is basically just a flat with that extra widening at the hips, if you like, at the tang shoulder. So when you're talking about trying to create a distal taper, if you want a strong blade that resists bending and resists, the kind of torque that you would put on it, say if you were doing a destruction knife that has like a lever at the end, then perhaps a stepped distal taper or no distal taper at all might be necessary. If you're trying for a flexible blade, like a filleting knife or a skinning knife or even a hunting knife or fighting knife or a dagger or anything like that, anything that requires a slightly more nimble and more cutting tip, then having a flat or compound distal taper is going to help you, because it's going to provide that flex, it's going to provide that little bit more, kind of piercing advantage, because it's going to have that narrower cross-section for penetrating things. And the compound is obviously going to provide you that little bit of extra meat at the shoulder if you want to have a very thin cross-section, but also worry about it breaking at the tang. And then the easiest is flat, because a full flat distal taper, you can literally forge it in or grind it in. It's very simple, because all you're doing is applying more material at the tang shoulders than you are at the tip. It doesn't require any special tools or any special knowledge. It's literally just thinner at the tip than it is at the shoulder. That's all it is. And so this is something that is, basic stuff. It's very easy to understand. You can do any of these and still have a good knife, but understanding where these distal tapers actually fit and what will best provide the performance that you're looking for in your knife, that takes a little bit more experience and understanding of the blade geometry and stuff like that, which we've discussed in previous videos. Distal taper and profile taper are incredibly important and work together to create the best geometries and the best balance and feel of the blade that you're going to get for the specific design you want. And understanding how to implement them is integral to becoming a really good bladesmith. Now, I didn't cover blades that distally taper towards the tip, so from the shoulder to the tip, because it's incredibly rare. In most cases, you are going to find blades that taper from the shoulder to the tip, purely because that shoulder area is where the tang is, and that's where the material narrows, and that's where it's going to undergo the most flexion, and so therefore having a strong and thick tang is going to help you with not breaking your handle off. Now, you can have a blade that is still front heavy that still has distal taper, and that comes down to using profile taper, like the Khanda, I believe, in Indian swordsmanship, which is a blade which actually flares at the end, much like the Berserker swords from Lord of the Rings, that actually is distally tapered. But it's also profile tapered in the opposite direction, which applies more material in that profile. So don't disregard distal taper for profile taper, and don't disregard profile taper for distal taper. They work in conjunction with one another, and understanding that is incredibly important to understanding the fundamentals of knife making. With that being said, I'd like to say a huge thank you to the commenter who actually suggested this topic, and also my fantastic patrons. These people actually keep this kind of stuff coming. They keep a hammer in my hand, they keep gas in the tank. They provide me with the ability to continue making this kind of content and keep educating people and sharing my passion for what I do. Without them, I would not be here. So thank you so much. And if you want to join this list of lovely people, there is a link down in the description below, or there's a link in the end card at the end of this video. And I would greatly appreciate anything you can give. You get access to behind the scenes videos and access to all kinds of vlogs and stuff like that I do for my patrons when I get around to it. I'm sorry, guys. But with that being said, I hope you have a fantastic week. Get out to your shop and make something. Don't do anything I wouldn't do. And if you do, make sure you film it. And I'll see you next time. Bye, guys.